For this video, I'm going to discuss solving vertex form quadratic equations graphically and algebraically, but specifically the goal here is to look at situations when the solutions are not going to be as nice as whole number solutions we've seen before. So I'm going to graze over the graphic portion because we've talked about that extensively in class, but I just reminder quickly, I can use this to find my vertex. That's why we call it vertex form, right 3 down 4, and then there's going to be a vertical stretch of that parabola from that new spot over 1 up 2, over 2 up 8, because of that doubling effect. And on the right hand side I have y equals 6, which is just a horizontal line. So it's a quick little review on graphing. Now for the equation solving. That went really fast. We have the equation and as a reminder we want to do the reverse order of operations. So if you put a number in for x and evaluate, you're going to subtract 3, then square, then double, then subtract 4. So we're going to undo all of those operations in reverse. So the last thing I did was subtract 4. I'm going to go ahead and add 4. Second to last thing I did was multiply 2, so I'm going to go ahead and divide 2. And I squared, so now I'm going to unsquare. It's the absolute value. So we take away the absolute values by considering two options. And this is the part I wanted to mention. The square root of 5, students who don't know much better will immediately take a calculator out and get a decimal estimate of the square root of 5. The problem is, no matter how many decimal places you leave, you will never have the exact value. Every decimal for square root of 5 is an approximation, just like 3.14 is an approximation for pi. So instead of turning this into a decimal and making it imperfect, I'm going to leave it in its exact form until the very end. So I have plus the square root of 5 here and the opposite of the square root of 5 here. I'm just going to add 3 to both sides in both cases. And then I can combine my two solutions into one by using plus or minus. So we have 3, which corresponds to my axis of symmetry. Feel good about that. And then we have plus or minus the square root of 5. And the square root of 5, well, that's what we have to do, is actually estimate to make sure it's suitable. So even though the square root of 5 is unknown, I can at least know something about it. See, I know the square root of 5 is smaller than the square root of 9 and bigger than the square root of 1. I chose 9 and 1 because those are perfect squares above and below 5. Oh, I could choose 4 too. 4 is even closer. The square root of 4 is 2, the square root of 9 is 3, so the square root of 5 exists somewhere between 2 and 3. That's just enough to give us an approximation, so you take 3 and you add a number that's bigger than 2 by just a smidge, and you're going to have 5 and a smidge, or 5-ish or so. And then if we take 3 and we subtract a little more than 2, we're going to be around 0.9-ish or so, and that is really consistent with the graph that I have here. Now if I was to go to Desmos, I would be able to verify even more that these solutions are accurate, but trust me, they are. And really quickly, just look at another example. Once again, I'm going to graze over the graphing part. This is a graph representing the two solutions I should anticipate. As for the algebra, we undo everything in order. And here, once again, we have a square root of 2. Leave it alone until the very end, so that you could express your answers or solutions in exact form. -1 plus the square root of 2 or -1 minus the square root of 2. Now this is one that you should probably know. The square root of 2 is approximately 1.4. I know it's going to be between 1 and 2, that should be obvious, but the 1.4 is, square root of 2 is such a common number that it's worth knowing it's around 1.4. So I could take 1, add 1.4, that's -1, and add 1.14. or -1 and subtract 1.14. So that gives us the following. Alright, so I hope you found this helpful. If not, sorry for wasting your time. But the main point I wanted to make here is sometimes when you're solving equations, you get solutions that are called radicals, the square roots of unfriendly numbers. And when you do that, you should leave your answer in exact form, but then go through and estimate so that you can verify it with the graph. And that you could also check these solutions against Desmos, which will not give you a radical form solution. It will only give you decimal. So you can check your work that way. Thanks for watching. Have a good day.